Hi, I'm Herb Gross, and welcome once again to our Math as a Second Language video series. And today we're going to discuss multiplication of decimals. Again, I'm going to assume that it's very easy for students to memorize the mechanical rule, and I'll go through a problem just using the mechanical rule as a way of summarizing it, and then show again how the adjective-noun theme takes the mystery away from why the rote memory type of algorithm works. Let's suppose we were called upon to multiply 3.14 by 2.7. What were we told to do? Pretend there's no decimal point and multiply the same as you would if these had been whole numbers. And notice, we don't even mention that we don't have to line the decimal points up. Students may be wondering, how come we had to line the decimal points up when we added and subtracting? Why don't we have to do it when we multiply? You see what's starting to happen? They're going to accept the mechanical recipe, but not really know, other than by the authoritative tone or the demands of the curriculum, that this is why you do it. That's the only way they'll know. It's just a bunch of rules to memorize. So what do? You multiply as if the decimal points aren't here. 7 times 4 is 28. Put down the 8, carry the 2. 7 times 1 is 7. The 2 you carried is 9. 7 times 3 is 21. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. I'm trying to make this sound as mechanical as possible. Now you add up the 8. 8 and 9 is 17. Carry the 1. 2 and 1 is 3, and the 1 you carried is 4, and 6 and 2 is 8. And so now the answer looks like 8,478. But wait, we're not done yet. Now what you have to do is count the total number of digits to the right of the decimal points. Well, there's 2 digits to the right here, 1 digit to the right here, so the total is 3 digits. Starting at the end, after the digit furthest to the right, count in 3 digits, 3 columns in the right to left direction. 1, 2, 3, and put the decimal point over here. And lo and behold, the answer is 8.478. Now you can get the answer that way. Let me show you, though, in terms of the adjective-noun theme, the logic behind these steps, which I think is very simple and ties in beautifully with what we've been doing all along. When you write 3.14, without the decimal point, it would be 314. Since there are 2 digits to the right of the decimal point, that means the noun is hundredths. 2.7, without the decimal point, would be 27. There's only 1 digit to the right of the decimal point, so the unit is tenths. So now this problem is saying you multiply 314 hundredths by 27 tenths. Now what was the rule for multiplying? The rule for multiplying was, when you multiply 2 quantities, multiply the 2 adjectives to get the adjective part of your answer. And look right away, there's where your 8,478 came in before you started fooling around with the decimal point. What did we say up here? Multiply as if the decimal points weren't there. Well, isn't that what we're doing over here? Not only is it as if the decimal points aren't there, the decimal points aren't there. They've already been replaced by the unit. And what is the new unit? If you multiplied hundreds by tens, 100 by 10 would be 1,000. So 1 over 100 times 1 over 10 would be, instead of saying 100 times 10 is 100, 100 times 10 is 1,000, you say 100th times a tenth is 1,000th. Okay, so now the answer in words is 8,478 thousandths. And what do I mean by in words? I mean the word thousands appears here. Now what if I'm not allowed to use that word? Well, 1,000 ends in 3 zeros, doesn't it? And that means that the decimal point has to be in such a place that there are what? 3 digits to the right of it. That means I have to move the decimal point 3 places. 1, 2, 3, not for any mechanical reason, but because that's how you translate the word thousandths into a decimal when you're not allowed to use the word thousandths. Okay? Now, the beauty of this is that we never had to use the decimal point until we had done all of the arithmetic. Now, you don't have to use the adjective-noun theme. I just think it makes everything clearer to use. Is it possible that you like the adjective-noun theme, but some of the students still don't get it? This is the whole point. There's no one-size-fits-all. You want to know as many different ways. Let me put it this way. It's fine for the student to know only one way. The teacher has to know several ways because one size doesn't fit all when it comes to helping students. So it's conceivable that the student still might feel uncomfortable using the adjective-noun theme. Is it possible that the students might have a different way that you've taught them? For example, again, looking at the problem 314 hundredths times 27 tenths, is it possible that a student is comfortable using fractions? In other words, again, 314 hundredths, the 314 is your numerator. The fact that the denomination is hundredths, 100 ends in 2 zeros, so you want to have a 1 followed by 2 zeros in the denominator. 27 tenths, 27 is your numerator. A tenth and 10 ends in 1 0. So in other words, as a fraction, 27 tenths is 27 over 10. Now do you have a rule for multiplication? Yes. Do you need a common denominator to multiply? No. Same thing that happened before. The same theme, adjectives and nouns. You multiply the adjectives, you multiply the nouns, and if I do that, what happens? The numerator is a whole number problem, 314 times 27. The denominator is 100 times 10, which is 1,000. Your numerator is the 8,478 that you got before. The 1,000 in the denominator says that the answer has to be thousandths. Thousandths requires that there be 3 digits to the right of the decimal point in the answer, and the only way you can do that is to count over 3 places to the left, 1, 2, 3, and the answer is 8.478 again. The beauty of mathematics is there may only be one right answer, but usually there are several correct ways to get the right answer. And again, as I say, if the students understand everything the way you're the most comfortable with, that's great. But usually what happens is there are some students that still don't get it, and so the more ways you have of explaining it to the student, the better a chance there is that you'll find a way that the students can relate to and internalize. And again, don't underestimate the value of a reality check. Kids today will sometimes say, I have a calculator. In the real world, this wouldn't bother me. I would just punch in the 3.14, I would punch in the 2.7, calculator would give me the right answer. Is it possible that when the student punched in the 3.17, they neglected to punch in the decimal point? In other words, they thought they entered the decimal point, but they either pressed the key too lightly or they omitted to press the key. The answer they would get wouldn't be 8.478 in that case. They would have got 847.8. In other words, even though they thought they were giving the calculator the problem 3.14 times 2.7, what the calculator got was 314 times 2.7, in which case the answer would have been 847.8. Well, here's what I mean by a reality check. Whatever the correct answer is, we know that 3.14 is greater than 3, but less than 4. And 2.7 is greater than 2, but less than 3. So whatever the correct answer is, it has to be more than 3 times 2, and at the same time, less than 4 times 3. In other words, the correct answer has to be between 6 and 12. Well, there are a lot of correct answers between 6 and 12. But 847.8 isn't one of them. On the other hand, 8.478 is in this range. At least it tells me that this is a plausible answer. It's conceivable I still made a mistake in multiplying. What if I wound up with 8.578 by mistake? I'd still be in the right range even though I was wrong, but it helps prevent me from making a very serious mistake. Now, again, what I want to emphasize is that as long as the digits stay the same, but all you do is move the decimal point, you will not change the adjective part of the answer. You'll just change the noun that it modifies. Let me take the same problem we just did. What were the digits without the decimal point? It was 314, 314, and this was 27. Let's do the same thing, only this time it's going to be 0.314, and instead of 2.7, it's going to be 0.27. And what I want to illustrate is that when we use the adjective-noun theme, we're still going to multiply the 314 times the 27 the same as we did before. All that's going to happen is that the denomination is going to be different. See, for example, 0.314 without the decimal point would be 314. And since there are 3 digits to the right of the decimal point, it's modifying thousandths. Without the decimal point, this would be 27. And since there are 2 digits to the right of the decimal point, the 27 is modifying hundredths. So when we multiply, we still multiply the adjectives. That's the 314 times the 27. See, that part here hasn't changed. What's happened, though? Now the denominations are what? Hundredths and thousands. Well, if you put 100 times 1,000 is 100,000th, right? So a hundredth times 1,000th, okay, when we multiply them together, is 100 thousandths. See, 100 thousandths, thousandths, hundredths, either way you want to say it. Now, what is 100,000? It's a 1 followed by 5 zeros. That means that you want 5 digits to be to the right of the decimal point. Well, there's only 4 digits here, so to get the 5th, see, I count over 1, 2, 3, 4. Now I've run out of digits, so I have to put a 0 over here, put the decimal point in. Notice that if I read this as a number, verbally, the adjective is still 8,478, but now it's modifying 100,000ths. And this is exactly what the mechanical recipe did. What did the mechanical recipe say? It said multiply as if the decimal points weren't there. Once I do that, this problem is the same as the one we did before. It's still 314 times 27. I still get 8,478. The difference is when I now count the number of digits to the right of the decimal point, there's 3 digits here, 2 digits here, that's 5 digits altogether. And you see where those 5 digits came from? 2 from the hundredths and 3 from the thousandths. Anyway, the mechanical recipe says what? Move the decimal point 5 places. Well, there's 4, I've run out of places. And there's my answer. Okay? And it's very, very important to understand this because students will be taught something. Let me give you an example. How did you learn to multiply by 10? Suppose you wanted to multiply 8 by 10. What were we usually told to do? He said, just tack on a 0, right? Annex a 0. To multiply 8 by 10, the answer is 80, right? Now, why was the answer that way? Let me just take a quick look over here. You want to multiply 8 by 10. And they said what? Just tack on a 0. Well, you see what happened over here? Written this way, the 8 is modifying 1s. As soon as I tack on the 0, what have I done? I've moved the 8 into the tens place. So instead of 8 1s, I now have 8 10s, and that was the logic behind tacking on the 0. See, every time I tack on a 0, the 8 takes on a new noun to modify. Tacking on 2 zeros, the 8 is still 8, but it's now 800. Tack on another 0, the 8 is still 8, but it's now 8,000. Here's the mistake that students will now make, and you can't possibly make this mistake if you understand what you're doing. Student says, to multiply a number by 10, we annex a 0 to the end of the number. Therefore, 0.8 times 10 is 0.80. See, is that what the student did? He says, here's the number, and I'm just going to annex a 0. Well, if you understand what we're talking about, what is the 8 modifying over here? Isn't it the first digit to the right of the decimal point? It's tenths, isn't it? What's it modifying over here? It's still tenths. In terms of money, what it's saying is 8 dimes is the same amount of money as 80 cents. You haven't done a thing to change anything, even though you annexed a 0. The correct algorithm should be to multiply by 10. we move the decimal point one place to the right. So in other words, what happened here, what you were really doing in terms of decimals, remember as a decimal, 8 is the same as 8.0. And if you now move the decimal point one place to the right, what do you get? 80. See? So in other words, 8 times 10 is 80 because we moved the decimal point one place to the right. If you have 0.8 and you move the decimal point one place to the right, you get 8. Okay? I think this brings us to a nice place to stop for the day. What have I tried to show you today? Remember, what I'm looking for is a way to teach math in a seamless transition as students go from one grade to the next. And I've found, after years of experience teaching at the developmental math level, that the adjective-noun theme allows us to have a smooth, seamless transition from one grade to the next. In other words, we don't have to learn one set of tricks for whole numbers, another set of tricks for decimals, etc., etc., etc. We have a unified way of doing these things. I hope that's coming through. And why don't we just pause then for the rest of today's lesson and just go back to our practice problem and finish up for the day. The practice problem says fill in the blank, and here's what the statement says. If 2,456 times 78 is 191,568, then 0.2456 times 7.8 equals blank. In other words, fill in the blank, what number goes over here. And this is the key point here. To understand what this lesson is all about, do not perform the actual multiplication. And as you pause the video to see how to solve this problem, see why this sentence is really saving you some work. See if you see that. And then, after you've worked out the problem, come back and we'll look at my solution. Now, here's the trick to this problem. I told you in the problem itself that when you multiply 2,456 times 78, the answer is 191,568. Now, look at 0.2456 times 7.8. Are the sequence of digits the same here? Without the decimal point, does this look like 2,456? Does this look like 78? Sure. In other words, what's going to happen here? You multiply as if the decimal points weren't here. Well, I've already multiplied it for you as if the decimal points weren't here. It would have been a waste of your time to do this multiplication all over, unless, of course, I had made a mistake in multiplying it. But it wouldn't make any difference because if this is right, then this is also right. The problem is what? That is just the adjective part. What is the noun? Well, there's 4 digits to the right of the decimal point here. There's 1 digit to the right over here. So doing it even the mechanical way, you want to move the decimal point 5 places to the left. 1, 2, 3, 4, 5. So the correct answer to this problem, without you having to do any multiplication and just counting the number of digits to the right of the decimal point, tells you that the answer is 1.91568. And again, you can give a reality check here. 0.2456 is pretty close to 0.25, which is pretty close to 1/4. 7.8 is pretty close to 8. So 0.2456 times 7.8 should be pretty close to 1/4 times 8. 1/4 times 8 is 2, and I think this is a pretty good reality check. Okay? So again, what was the importance of this problem? To understand that the sequence of digits determines the adjective. The decimal point simply determines what noun the adjective is going to modify. And that brings us to the close of today's lesson. I will look forward to seeing you next time when we talk about dividing decimals. Until next time, be well, stay young, have fun.